Hi, so in this video I'd like to do some math questions from CLAT past years. We'll just be doing from CLAT 2013. So in my last video I talked about how to approach maths in CLAT. So the first thing you do is list out all the givens, right? So you list givens. That means given quantity, say if it's a compound interest problem which we did last time, we list out the interest if that is given, right? Whether it's annual, semi-annual, the time period basically, the principal, amount. Alright, so whatever information is necessary, you list out all of them, right? And so first you list out everything that is given. Second, you move on to the unknowns, right? And then you assign them variables like x, y, z, right? And then you try to find the relationship between knowns and unknowns, right? Right, so this relationship can either come from, say, formula, like for instance simple interest equals to PRT by 100, right? This is the SI simple interest formula. So it can either come from formula or it can be given in the question. For instance, something like amount equals to 2 times the principal, right? Something like this. So then you list out these relationships and form an equation. So that, I mean, an algebraic expression. You get something like x plus 3 plus 2x 1 by 21 equals 4 or something like that. You basically get an expression, right? You try to get it down to one unknown and then you solve that expression, to get your answer, right? So this is not as complex as it looks, right? But this is how you approach, and this is like the universal solution to all math problems. Universal, irrespective of the topic, you can apply this, right? It can apply for all topics. So I wanted to do a video to for practical examples of this method. So let's quickly go to the CLAT 2013 question paper and then find a relevant question so we can solve it using this method. Okay, here it is, right? Okay, so this is factual, like this question, the angle in a semicircle. So but you can let us first apply it to this question. I know it's ridiculously simple, but I think it'll be more comfortable because students generally have a tendency to fear math. So let's list out the knowns. So angle at semicircle. We don't know, leave it. Angle at circle, which we know is 360 degrees, right? So this is 9th 10th standard maths, so you should be knowing this angle, right? So ratio between circle and semicircle equals 2:1, right? That means a semicircle is half of a circle. Semicircle equals half. Right? This is what this means. I mean, this is exactly what you do while you solve this question, but you just do it in your mind, right? So I'm just trying to show you that these are the steps you anyway follow, right? So and if you keep practicing these steps like this, the 4 or 5 steps I listed before, you keep practicing this, all the irrelevant details will quickly be calculated in your mind and you just proceed with the question. So it will improve your speed and efficiency, and there won't be a single question which you aren't able to solve, right? Provided you know all these information. If you don't have these information, then you can't solve them. Then you skip them and move on. You can't guess, right? And we also know that 360 can be represented as 2 pi. Again, this is a 9th 10th standard mathematics. Pi is 360 equals pi represents 180 degree, right? So alright, so the angle in a semicircle, so let that be x, right? So you know the angle in a circle is to the angle in a semicircle will be the same ratio as the circle is to semicircle. So 2 pi by x equals to 2 by 1. So this implies x equals pi. So this is the answer, right? So the answer is A. So this is how you go about when tackling maths. I mean, this, you people might know it from before, but I just wanted to show you the steps in this question. Now let's actually go and do a proper question. Alright, so let's do this question. This is a seemingly complicated question, right? Let's do this question. So here it says kx plus 3y minus k plus 3 equals 0, right? 12x plus ky equals k. The value of k for which these two equations will have infinite solutions. Alright, so these are the two equations. I have to find the value of k for which these two equations will have infinite solutions. Okay, so now this is slightly complicated, right? But it's still very intuitive. I mean, I'd say it's a very good question, and I wouldn't say it's a supremely difficult question. It's very easy for someone to figure out. So here, don't think of k as another variable, right? So k here is not the same as z in this equation. I mean, I'm using z because xy is there. So k is a constant. Here k is a constant. So k is closer to a number than it is to x or y, which are variables, right? So what you have to find out is for what value of k will these two equations be same or be in proportion. I mean, ideally these two equations will be same, right? Why do I say same equation equals infinite solutions? Why do I say that? Okay, so this is the question we're talking about. So why do I say same equation equals infinite solution? It's very simple, right? Because you have two unknowns, which is x and y, and you know you need two equations, right? You know you need two equations to solve for this. But what happens if you have one equation? What happens when you have one equation? You can't solve, right? So you can't solve for this if you have one equation. So and then the solution becomes infinite, right? So in this case, what you have to do is find a value of k for which these two equations are same, right? Now the question becomes ridiculously easy. So these are the knowns I have listed out. These are my knowns, right? So this was something you could have worked out on your own if you didn't get scared, right? So these are my knowns. I have listed them out. Right? So if you didn't get scared, you would have been able to work this out pretty easily. And the portion that k is a constant, that only comes with practice. I mean, practice, right? So if you have enough practice, you'll start recognizing when is the question asking for a constant and when does the question want you to assume a variable. So here k is closer to a constant, right? Even though you have to find the you don't know the value of k, you know that it's a number, it's a fixed number which you have. So you only have to find k, you don't have to find x and y. Basically what I'm trying to say is that k is very different from x and y because you don't have to solve for x and y. So k here is the constant for these two equations, right? All right, so let's solve it then. Right, so we have reached this equation, right? So how do we go about solving it? So we know we need to get these two equations in proportion, right? In the sense that they either these two have to be exactly equal, or this has to be in a ratio, like it's 1:2, or maybe 1:3, or 1:4, whatever, as long as these are integers. Basically this has to be, say if there's an equation saying x plus 2 equals to 4, then this must be something like 2x plus 4 equals to 8, or 3x plus 6 equals to 12. You get the answer, right? I mean, you get what the relationship between these two equations are, right? So how you, so we know that these two equations have a ratio. So basically the coefficients of x, the ratio between the coefficients of x, which is, right, will be equal to the ratio of the coefficients of y, right, will be equal to the terms without x or y, right? So don't get flustered over this. So look at this equation, right? So if you multiply this by 2, the coefficient of x, which is 1, right, here the coefficient of x is 1. So if you multiply this entire equation by 2, the coefficient of x is multiplied. This will be 1 into 2x plus 2 in, oh sorry, this will be y, right? So 2 into 2y plus 4 into 2, right? You get it? So each of these are multiplied separately, like the coefficient of x, which means the number in front of x, and the coefficient of y, and the constants, these are all multiplied separately, right? So if I'm saying these two are equal, then they'll all be multiplied by this integer number, right? So they will all be have the same ratio, like here it's 2, in this case it's 3, right? So x got multiplied by 3, so y also got multiplied by 3, and 4 also got multiplied by 3. Similarly, if these two are this have the same relationship as these equations, then their ratio will also be the same. So how do you solve this, right? I'm not sure if you've come across this, but how do you solve this? So you solve this. Here you get x square equals to 36, so x equals to plus minus 6, right? Then you solve this. Here you get minus 3k equals to minus k square plus 3k. Taking all that side, so this will be k square plus, no, sorry, k square minus 6k equals to 0. So k common, k minus 6 equals to 0. So here k equals to 0 or plus 6, right? So basically it's the common solution from all of this which is the correct answer, because whatever solution has to satisfy all these equals, right? So here the plus 6 and plus 6 are both common, so plus 6 is the answer, right? So let's just check if, yeah, so option C is the answer. So how do we check this answer if our answer is correct? Let's put plus 6 into these two equations, right, and see what gives. So it says 6x plus 3y minus 6 plus 3 is to 0. This is 6x plus 3y minus 3 equals to 0, and here it's 12. So this is the first equation, right? This is the first equation. So let's do the second equation here. The paucity of space, 12x plus 6y minus 6. So you see equals to 0. You see this is exactly the double of this. So you multiply this equation by 2. So this will give you 12x plus 6y minus 6 equals to 0. So here the second equation is exactly the double of this equation. So they both are ultimately the same equation, right? So now you cannot solve for x and y because they have infinite solutions, right? So this is how you go about solving these questions. So what we did, like if you look at the method, first we listed how to get, yeah, let me just try to. So first we listed how to get infinite solutions, right? So this was our first, so this is what we did first, right? Then what we did was, so once we found out how to get infinite solution, which was to make the two equations proportionate. Sorry, equations proportionate. So this was what we did. We made the two equations proportionate, right? Then we went about framing equations. So how did we frame the equations? We took the ratio of k's for each coefficient, for each variable. Like, so each ratio, actually for each coefficient, right? So then we came up with a triple equality and then we just solved it, right? So I said double equality and then we just solved it. So you basically, what you needed to know to solve this question was this, that how to get infinite solutions. Second, okay, this is something you could have figured out, even this is something you could have figured out, but I mean, this was a little difficult to figure out. This wasn't very difficult to figure out. This also was something which you could have figured out, right? How to solve like double equals, like 3 equation 1 2 3 the 2 equals. This is not something which is very difficult, but this is ideally something you should know. I mean, I know some good books in 9th and 10th grade have equations like this. Otherwise, what you can do is just break it, right? And it's the common solution to all three of them. This is also something which you can figure out. It's not very difficult, right? So this is something you can figure out. So this is all we did to solve this relatively difficult question, right? So that's it for this video. In the next video, I'd also like to tackle some of the more conventional questions. Today we just did one easy question and one difficult question. Next video we'll do some of these normal questions like this, and yeah, so hopefully you'll end up building more confidence in maths.